Hi, I'm Bryan,
And I'm John.
and we're hosting the Pioneer Park podcast, where we bring you in depth conversations with some of the most innovative and forward thinking creators, technologists, and intellectuals.
We're here to share our passion for exploring the cutting edge of creativity and technology. And we're excited to bring you along on the journey.
Tune in for thought provoking conversations with some of the brightest minds in Silicon Valley and beyond. Hey there, welcome to the Pioneer Park podcast. Today, we are having an interview with Dr. Cinjon Resnick, who likes to be at the forefront of tech and research. He has worked at startups, spent time as a fellow at Google Brain, and recently wrapped up a PhD in machine learning from NYU. He's an alum of South Park Commons and is currently working on ideas related to AI-powered experiences, games, and companionship. Sinjon, welcome.
Thank you. Appreciate it, guys.
So I want to dive right in. Tell me about Ender's Game, your relationship with the book Ender's Game, and the cool game that was featured there. I guess it's called Mind Game in the book. What is your memory of reading that, and what inspired you about that narrative?
Ender's Game is wonderful. If you haven't read it, I highly recommend it. It's a story about a whole family. And this family they're special, but in particular, this one boy ends up taking on the mantle of savior of humanity through a simulated adventure experience. I'll leave it at that and let the audience go and read it. But in particular, inside of Ender's Game, there is a story, and the story is guided by this thing called mind gaming. In this story, Ender goes on an adventure. It's not meant to be beaten. It's meant to test different aspects of the character. There's some fun things that happen, but this was a companion for Ender, an interactive companion. It was similar to a Diamond Age where you have this concept of the primer. The primer is an interactive like Socrates for the child.
We're dealing with a set of technologies that are potentially opening up the doors towards unstructured discovery to play games experiences. And it sounds like that's a lot of the areas that you're interested in developing your work. What do you think are the experiences that are opened up by the current generative AI technologies?
Yeah, it's a good question because if you think about what life was like for 1700s, 1800s child, either you had nothing or you were very wealthy and then you had teachers. Those teachers were one-on-one personal tutors. So Rousseau talks about this and Emily and like this idea of a personal tutor that you have for you. And so Socrates was this famously for different wealthy patrons, children, wealthy patrons. What would be really cool is to provide this for every kid. There yet, probably not exactly in this document that I wrote, sort of go through where exactly we need to fix and what are the remaining problems to be met, but we're pretty close and we're closer and closer each day. And so the opportunity now to gear an AI, if you will, towards a child's ability, towards a child so that it is a personalized experience for them. They want to learn, where they want to go, what stories they want to play to play out for themselves and really have that AI be something that is not just comfortable for not just a great experience for the child, but also something the parents want close. And so I think that today is time to really start thinking about that and maybe even building towards it, finding some initial wedges.
Are there some kind of maybe early applications or milestones on that journey that you're the most excited about that we could potentially be close to delivering?
Yes. So I think that one very clear one is actually everything that's happening in language learning. We see companies like LingoStar, I think Speak is going to go this way as well, where they're developing applications that you could imagine just plugging a child into, or yourself as an adult language learner, and figuring out, okay, this is how you understand French in the context of actually talking about it with AI. And from there, the interactive experience actually looks pretty similar to the interactive experience when you're language learning with a human. The thing that the gap that's missing there, there's two things actually that's pretty clearly missing. One is the empathy to know where the student is on their, and also on a day-to-day, how they're feeling, how they're doing it. Do I up the capabilities of this AI or decrease them, et cetera? And the second one is just having a curriculum for the student, because it's not just this interactive experience, especially with adult language learners. There's also this idea of at some point you are teaching them. You have some objective in mind for where they're trying to go. That's missing, but I think that we're on a path to be able to get there. And Speak, they already have tons of users, and I believe South Korea. LingoStar, they're trying the same idea. They're demonstrating the capabilities of this.
Have you heard of Bloom's Two Sigma?
Yeah.
which for anyone listening, that's the idea that learning or any kind of learning that is taking place with a single tutor. So the impact of having a personal tutor on learning is 2 sigma greater than the sort of base case, basically making the case for individualized tutors and individualized education. And Bloom's 2 sigma is like a pretty prominent result in educational theory, and I think speaks to the fact that these personalized Aristotles or these personalized coaches have a big impact on education. So I suppose what you're proposing is that we might be at a point where we can make these personalized tutors and be achieving much more significant educational results for a much larger portion of the population.
That's right. That's right. So I have some background in some of this stuff. I've not been a teacher per se, but I do regular personal tutoring in circus. So I have a teacher in the circus apparatus that I trained, and it's just night and day whether I'm working with one of my coaches. Similarly, when we've tried to do things around, I ran a nonprofit called Depth First Learning for a while, which the whole goal there was to try and figure out a different way to learn from a structured base. I'm not going to go into the exact details of how this is, depthfirstlearning.com if you want to check it out. But what was interesting there was when you put people in a group rather than having them just be alone, it works out much better. Why is that? I think a big reason is because you get to learn from what other people are doing, where other people are going, where their knowledge is coming from. And so if you have a particular entity who's geared up to understand the topic better than you and to be able to go on this journey with you, but is also tuned to knowing where you're at, it's very powerful. And this is a lot of the things that you're pointing out, let's say with Bloom, et cetera. So one thing that's really cool about doing this with language learning is that it's largely just about talking. And so the subject matter is really easy. It's hard to get it wrong. A lot of these machines, they'll hallucinate answers today and they can get it wrong, say in history or in finance. That's a problem. Another area where I think is very primed for this concept is in early childhood interactive experiences, because getting it wrong just doesn't matter. To a kid that's 3 to 5 to 7 years old, getting something wrong in their story of their day or talking about a big dog that is drooling in the park, and that doesn't matter if it's slightly, but the experience of making a companion that can actually have empathy with this child, those are the things you start to be able to build there. That's the direction I've mostly been looking at.
I'm curious if you've had any mentors or teachers that you feel have been really effective in your life in cultivating that experience for you that's made you so interested in this.
What exactly are you asking? If a teacher of mine has actually just effectively been a one-on-one tutor?
Exactly. Whether or not you've had a really sort of significant relationship with somebody who's a mentor or a tutor that kind of really you felt opened up a new field. It sounds like to some degree, circus has been that for you.
Yes, yeah, I can definitely answer that way. So in athletic movement, I have 2 coaches in Montreal that I train with. One, this guy, Victor Fomine, who's a world famous coach. I'm really lucky to be able to work with him. Another guy, I think is Sergey. And I go to them for different things, but and Victor also doesn't speak English. So the opportunity to work with them is just fantastic because they understand so much of how the body should move. And so the whole experience with that is getting cues, figuring out, okay, so you should be doing that. So you're doing that. And so just the cue to tapi, look at the ground, look at your feet, just hearing that over and over again at the right time is fantastic. It's just so useful. But then sometimes I can go there and I'll see him teaching people who have much less skill or even much higher skill. And he changes his course to those, right? There's an empathy for understanding where they're at, but then still this drive to, I think one of the best parts of working with a tutor who's able to adapt to you is you give more and they give more. And if it's a day where you just can't give that much, they recognize that. Being able to build that into this next generation of machines is going to be so important for getting this tutoring experience.
One last aside on that. What is your circus skill?
I do straps. It's like artistic ring.
What was the inspiration for your recent hackathon project that you did at Subpro Commons?
Animate. You're talking about Animate. And the idea here, just to sum it up for the audience, is I wanted to understand what was the state of the art in a wide variety of systems. There's a wide variety of APIs that we could use to have an interactive experience with AI. And additionally, I also wanted to understand what it would be like to test 2 things. One, is it fun to be read a story to? And 2, is it interesting for a language learner to be read a story in different languages, in like the language that they're thinking about. At this point, I hadn't yet come across any app that could do this thing. I have in the time since. But the Animate then was we took a chapter of Alice in Wonderland, we turned it into a visual story. So you could see a scene with it. And there's a narrator, there's two characters. And then we wanted to have for each of those characters, them talking out their role. So in other words, we turned it into a play. Yeah. And the whole experience of taking the story, turning it into a play, and then animating the play so that you have the characters with their mouths are moving. Then then there's the language switching and the interactive experience. So the main goal was really to test, is it interesting to be read a story to? What would make it interesting? And is there something around language learning there that can tap into? So built all that out. It was actually rather quick to build it all out, considering the technology today is very good, progressed to the point where you can do all these things. And the goal at the end of this was to then put it before some children and see what they loved. And when I did that, there was just one thing that stood out over and over again, was the ability to change the scene. It's just fun. It's a fun experience when you edit the scene and you go from something which you can see it's playing as a canvas. It's a creatively constrained canvas because it's characters sitting in front of a fireplace with a chessboard in between them. But then you say, oh, I want to put a monkey on the chessboard, or I want to change this chair to be a giraffe. And what you get back is just fun. It's surprising. It's creative. It's interesting. It's hilarious. And it was engaging watching the kids actually play with it.
I'm curious, you are very interested in games and play. Do you play any games?
I do. I really like social deception games. So famously like Secret Hitler and Coup, those kinds of games. But I also Braid, and I used to play a lot of Diablo 2 when I was a kid, and Warcraft 3.
Do you spend any of your time now deeply invested in any kind of computer worlds? Or most of them are sort of social deception?
Ooh, I don't really play any computer games these days. I am going to play Diablo 4 when it comes out. I have a childhood nostalgia around it, but I have not invested in any of the ones that I've noticed my friends playing. I never got into Factorio.
Do you feel like the next generation of games, Factorio is a great example of a game that is algorithmically generated, but has a lot of randomness embedded in the way the game is played. It's very famous for being replayable and time again. Every experience will be different. Do you think that generative AI, and I guess how do you think that generative AI is poised to impact gaming?
Good question. So I think there's some obvious answers here. Things you can point out with AI Dungeon. You could talk about storytelling, whatnot. I think there's two things that maybe are less obvious. One direction is around motion generation. So we're starting to see over this past year, motion generation start to work. What I mean by this is examples are FizzDiff or the motion diffusion model. These are pointing to a place where you can just say, I want this character to move like Beyonce in a rainstorm with jazz music. And then it does some interesting thing because it has some concept of Beyonce rainstorms and jazz music associated with the movement of the human body. We're not at a point yet where we can do this with shapes that aren't really the human body, unless you can slap a faux human body on it. But what that means is that if I was to just draw something that had some resemblance to the human pose, you could imagine turning that thing into its own shape. And so this could have a huge effect on UGC content. Some of the UGC content can become alive. So I've seen a couple of startups working along this directions, not the direction of taking the motion generation and putting it in yet, but being ready for when that's possible. So that's one area. Another area which I think is really promising and I know is actually being worked on in places like EA, is defining difficulty differently. A lot of times in game difficulty, what is you see a computer get better or stronger just based off of, I'll give it bonuses to how much gold it collects when it accumulates something. It's just hacks. But if instead what you can do is define it in terms of how capable it is as an agent, and that capability adapts to what your strengths are. So you're doing really well. So it'll just keep upping the difficulty until you're in that sweet spot of just a little bit past what you can do, but you strive hard to get there. I think that's going to come. That's going to come pretty soon.
Yeah. So like I play online chess, and I think the thing that is very cool about it is that you have your ELO rating and you're always paired with people who are a good match. And it was always disappointing. I remember as a kid when I realized that like in Civilization deity mode or whatever, like all that was happening was like the bots just like could build every building in 3 turns or something. I was like really disappointed. Like I thought, oh, the bot's going to be like super intelligent. It's going to outsmart me. And that's not actually how it works. And you just kind of have to figure out what hacks you can do to exploit its dumb behavior. Yeah. It's like a completely different idea to actually make it be really smarter.
Yeah. Yeah. I think places you'll see this first are things like FPS. In chess, you could do this right now. You could train AlphaGo to have any ELO rating you want.
Yes.
And then just park it on the server and have it be available to play.
Yeah.
I don't know if anyone's actually done that though.
I actually think so. So I for sure heard about people building chess bots that are intended to have a certain ELO rating. And then I believe actually that on chess.com, some of those bots like are actually, specifically trained to behave like a human would behave if the human had that ELO rating.
Yeah.
I think some Go servers also have similar bots that are out there at different levels with different sort of training and background. So very interesting to think about. I recently read the paper about diplomacy, the Cicero paper from Facebook, which was talking about the integration of large language models into this sort of like social strategic game. And that was one of the most fascinating examples that I've run into in recent history of an integration of a very complex social game with a strategic engine. I'm very fascinated to think about what is the sort of next version of this. Are there environments where we could let these things loose to learn from it proactively? A lot of these things, especially the strategic engines that AlphaGo and these other sort of game engines that are winning these strategy games, rely on self-play, hundreds and hundreds of games to be iterated upon in the background, playing each other. And I'm curious, do you think that in a social game or a game that is almost dependent on relationships with humans, do we run into an issue where self-play becomes ineffective because we can't actually mimic human behavior? We can't mimic human adaptability.
What is the game you're thinking of where you need to do that? I guess I'll point out my example as being in AlphaGo, once it passed human capability, it kept getting better because it was now competing against its own population.
So the example of diplomacy, I think, is somewhat interesting because it is reliant on human communication. It's reliant on interpretation and alliances being effectively formed. So perhaps there's a category of games that do have this sort of like unbounded social nature. And self-play, when they used self-play in the context of diplomacy, they found that a large part of diplomacy, first of all, takes place over messaging, basically convincing people to ally with you or to invade another country on your behalf. And so that requires that you're able to be persuasive. And when they instituted self-play in this system, they found that there was a tremendous amount of semantic drift where system one and system two were communicating with each other and they were beginning to use nonsensical language to. And so that seems to be the limiting factor on how well a computer can do in a sort of social setting or a setting where a computer needs to be persuasive. It seems like there needs to be some sort of anchor to the real world.
Yeah. Yeah. So it's been a while since I've been involved in this research direction. I would say the thing that comes to mind is called other play. Like, I haven't seen that. I would look into that. So other play is this work out of, it was also actually originally at FAIR, but I associate it more with Jacob Forrester and his lab. The idea behind other play is that you want to train agents that can work not just with themselves, but with other agents. And so the goal the whole time was to be able to train agents that play Hanabi with humans at a very high level. And so the algorithms that they come up with around this, even though they're playing self-play, need to be able to work with humans too. And they actually do a pretty darn good job. So a lot of that, I think that there's a lot of room for algorithmic improvement where you go in those directions. The challenging part is always going to be to keep the human connection available there. I think though there's another question that's built into what you're saying, which is, can you make an algorithm that doesn't actually work with humans, that is agents getting better and better, but still it's human interpretable as to what they're talking about? Right. So it doesn't necessarily need to be playing with humans, but it needs to be talking in a way that humans can understand, or that's what we would want. And one question here is like, if it's even possible, because maybe what they're saying looks interpretable to humans, but actually has codes underneath all of it. And so that's I think an open question. I don't actually know research that has addressed any of that, but I would expect that to actually happen. that once it surpasses the human, trying to understand the strategy involved is too difficult. And at some point, it's going to be so difficult that we're just going to let it happen anyways. We're going to let it happen because the results are so good. And you could take that as foreboding even. I'm not sure.
One of my favorite conjectures that John has about the future is this world in which there are just natural language APIs to the universe. So basically, every sort of site or service has a natural language API where you state your intent and it is able to perform the actions. And you can have obviously these APIs that are beginning to interact with each other, just like a large API server, but they're interacting with natural language. But what I think is interesting in that context is what happens when natural language ceases to mean what it means to us, when these bots
That's right.
are
That's right. Yeah.
going to communicate in their own version of our language that to mean very different things.
Yeah. But I love that direction and emergent communication. And as one of the reasons I wanted to do a PhD was to study that area. And I think that there's a lot of fanciful things that we can come up with in that domain. It's hard to then ground it in a real, actually useful thing to do. And we've seen now the rise of agents that we can talk with. And we used to call these 3 years ago, we used to call these chatbots. And now we don't. We call them, we've forgotten the word chat. Instead, we go just ChatGPT or GPT-3 or the coming one from Google, whatever. But they work now, and they work in a way that eschewed all of the purpose that was going on with emergent communication. But maybe it's time to bring it back in. And I would love that. I think that would be amazing. I also want to bring up something else which I think is interesting in this direction. And that's how it's sort of connection with hallucination. The hallucination in terms of is the big language model. So my friend Colin has this interesting take. He says it's BZIP. It's pretty hard to imagine these neural nets being more compressive than BZIP. And BZIP is roughly n over 4 in terms of if you're using float 32. So if you resize of your language, just 25% it, that's roughly BZIP. Let's just say that's a floor. Okay, so then we're going to move on from what Colin's point is there, but that's our floor. Now, if you imagine all of the internet, it's ever generated, much larger than the size of these models. So if you imagine stuffing all of that into these models, it's not going to be able to do that. In the same way that you and I, when we go around the world, we can't stuff everything into our head. We have to compress it. We have to figure out how to make it compositional. But it's not going to get below what BZIP is doing because it's not even caring about me.
You can do it if you're lossy, right?
Yes, that's exactly it. So you get your lossy, and that's where hallucination comes in. Because we don't give it any faculty for knowing for knowing that it doesn't know something, and we require that it generates something, the only answer is that it's a lossy hallucination. It has to be. And if you were to instead figure out some faculty for either having a reliable communication channel that lets it say, I don't know what this is. If you never do that, you're not going to get, if you don't do that, you're not going to fix it.
So what do you see as solutions to hallucination in the short and medium term?
I think the first question is to ask yourself if you need a solution. Because a lot of times, maybe you don't need a solution. Yes, you're going to need one if you're trying to do something that's legal obligation. If you require that this thing is airtight in the domain, then you need a solution. But in many places, you don't. And ask yourself really if you do. The second answer is at some point we need to teach it, or it needs to emerge, because it seems to be the flavor of the day. It needs to emerge a property of understanding what it doesn't. And there are places people working on that. But even the direction of, say, involving knowledge bases inside these things. So people have been doing this for a while. It's not like in the last year and a half was the first time that we started to understand that this stuff can hallucinate. People working on summarization for decades, extractive versus abstractive summarization. This is not a new topic. We don't have an answer, even if you include knowledge base, because the network may actually have a concept of knowledge base. Sorry, the model may have a concept that this knowledge base exists without being able to actually point to the fact that caused it to understand something. In other words, I don't think there is a solution right now. And I think you have to deal with how much you want of it, and then otherwise form the right gates. You form the right playpen for your users or whatever to play in.
Yeah, it's interesting your point about the fact that it can't say that it doesn't know. Like, it makes me wonder if you could instruct them or something to be able to ask the follow-up question, like, how confident, or were you sure about that? And have it reliably give you a reasonable response or that kind of thing.
It's unclear that would help, right? Because it's the same problem. It's like, at its core, it just doesn't have the ability to do this. Again, unless something emerges that's different, but we haven't seen that. Instead, what it has, I've seen really good evidence to suggest that what it has figured out is the ability to follow your intent, the conversational partner's intent. So if Bryan's talking to this agent and it knows what it's looking for is some answer along these lines. Like, why do you not know what you know? What do you mean? What I don't? Is it because you are trying to track this fact? Oh, yes, that's why. And then you roll the dice again and says, oh, no, that's not why. It's actually this. But the understanding that it seems to have some understanding of your intent to where it's going.
Yeah.
That's
The
interesting.
way I phrase this is they seem to be very agreeable. And
Yeah.
I suppose that's because a lot of to your point earlier, like these are trained on data that exists, not data of just denial of existence. And I think it's interesting. It's perhaps an interesting point to think about the negative case of not knowing is not represented very well in the data that it's trained on because overwhelmingly the internet is full of information, even if the information is false. It's not full of people, or I guess we have an underrepresentation of questions not being answered because the questions that it's being trained on are content. So it's almost as if we have this bias towards the things obviously that do exist, the training sample that do exist. And perhaps there would be a benefit to generating false or negations as part of its training sample. One other strategy in this domain that I'm curious to hear feedback on is relatively annotation heavy. And that would require basically taking the input of something like Wikipedia and annotating it as requiring citation or being basically labeling as this particular statement coming from needing a source or being an example of something that is a timely factual piece of information and thereby perhaps teaching a model in its process of training that it needs to basically inject some citation or inject some sort of timely fact. And knowing that and being able to output that as part of its response to then be filled in so we can imagine, for instance, a tag that indicates a timely fact or a sort of citation needed that's actually in the data as it's ingested. That's just one strategy to throw out there. I understand that it might underlie some of the experimentations with the FLAN model from Google, but curious if you have any reactions to that sort of strategy or others.
I think that it's a great strategy for targeting it towards your use case. If you care a lot about having, let me put it this way, the model size isn't changing. So you still have this limitation, this more meta limitation around, can you actually put all the data you need into this thing? It's comparable to you as a human. Actually, it even has fewer parameters and abilities right now than you as a human. But at some point, it'll be comparable in terms of parameters in its head. And you yourself can't remember everything that happened. There's just too much data. And so the answer must be that it has to compress it into compositional ways and then use those compositions to meld into these new concepts and then be able to explain them. But even us, when we do that, we still don't remember facts because there's too much information there, and it's too long tail. I don't anticipate that changing.
What do you see?
Why would it change?
What do you see as the limits of AI-driven storytelling? What's the boundary in its capacity to proactively create?
It's interesting. I think in the long term, I don't think that it's not bounded. I think that it'll gain all the faculties that we want it. I think today, one way that it's bounded is definitely in the empathy and understanding of what's going on. If you try and say, okay, you're playing the role of a teacher or a 5-year-old child, it's not going to remember the entire time that it's playing with a 5-year-old child. That's one thing that comes up. But at some point, the child's going to say some sort of information and the model, it's not going to know that tone means something. There's no ability to take that in. If you say the kid was excitedly saying it, are you saying it with the right way that we gauge it? There's a lot of lossy information there in how humans receive empathy and give empathy to get where the child is at. And I expect that'll be true for us as well. When we put that back to adult language learners. When I've taken language classes or just one-on-one experiences with teachers, they have this ability to slow down the way that they speak automatically to gauge when they figure out that you're not thinking about the right thing. Or they can stop and say, oh, you didn't get that word, did you? Or on the other flip side, they can speed up when they recognize, oh, you're fine. You got this. Let's go faster. It's not going to be able to do that automatically. So there's going to be this little bit of extra friction every time you use it, where you need to now account for that with design. I think it's possible. And it's a very interesting journey in the next 10 years, getting from here to the next step.
How would you try to get it there?
The answers that come to mind feel like a combination of getting the data and getting the right design today, and also just we need to reduce the latency in things like speech conversation. So in a past life, I've worked a lot with audio data. We're talking 16 FPS, 16 kilohertz, then you're talking tremendous amount of samples per second. Models today can deal with that, but it's a whole other modality compared to text, which is much fewer samples per second because each of those samples, fewer words per second, because each of them contain a lot more information. So if you want to be able to go from the experience that we're having right now, where I'm talking and you immediately understand it because there's no extra steps from taking this audio text to sensory, to reasoning and then reasoning back out to text, that pathway needs to be smoothed. And there is some really interesting work going from audio to audio, but most of the big labs are not focused on it because there seems so much power right now go into these straight up text to text models that they're going to focus on them for a while. If you want to get to a place where it feels like real-time understanding and real-time, maybe even empathy, it's possible that emerges from the text, but it's going to do it in a medium that doesn't feel the same as it does with you and I right now, or what happens when you play with a child. And so I do believe you almost surely have to go to an audio to audio experience to get there.
It feels like there's almost like a multimodality to this, where you can think of it as being the text itself is like on one mode, and then all the kind of like meta text audio information about the way the person's talking or their speed of speech or their accent or whatever, this other stream that you're actually going to want to co-process as you're then making judgments.
I agree. Yeah, I agree. I think that there's so much interesting questions around prosody that we don't really understand. And sure, there's entire other fields that look at the effect that comes with different prosody. But bringing that into the end-to-end experience that's powering the advances today, we don't have good answers yet. And there are teams working on this. There are teams at Google, at Facebook that I'm familiar with that they're not even private about it. They're public. They're fairly public about the fact they're trying this because it's all early.
So Bryan and I, for our hackathon project, we made a voice chat bot that you could call on the phone. Awesome. And it was, honestly, I think the coolest thing about this project was having that experience of talking to a bot via voice and then seeing how it's cool and also how it's broken. And so like when we first turned it on, we used Curie as the model, and the response time was about a couple hundred milliseconds. And it really felt like Curie is like listening to us and then answering back. And it is really magical just to have the bot be talking in a conversation flow and cadence that matches yours, at least a little bit. But then Curie was difficult because Curie hallucinates a lot. Still fun. It's fun that Curie hallucinates actually. But it was like, I had weird conversations about it where it told me there was like a terrorist attack going on and stuff. And it's okay, you can't really ship that. But it was creepy. Like it was almost like just, there's like a freakiness to that. But then to get reliability, we switched to DaVinci, and then it was like 3-second lag time or something. And then you just kind of feel like you're giving instructions to Alexa or something.
Yeah.
That's magical. And of course, like, I mean, to your point, man, if you could get that curiosity and then also have the bot be attentive to and the kind of like other aspects of your speech that are reflecting your state of mind. Like I could imagine that even if it was just not very smart, like being really magical feeling.
Yeah, it really would. And that doesn't account for the TTS and the ASR on the other side, or the text to speech and the speech recognition on both sides of that.
Yeah.
That's probably adds another few hundred milliseconds each way at least. Yeah.
This is, I think, evidence of how amazing it is to be a social animal and to have a brain that is capable of interacting in a real-time, interactive, perceiving, understanding, reacting, all happening so quickly. and it speaks to the fact that there's some amazing compression representations of our world are extremely efficient and in their ability, both in terms of a memory standpoint and also in terms of a computation standpoint. And I wonder whether or not that seems to me from where I'm standing to be one of the main limitations that of our current sort of understanding of how AI will progress is we are very far away from being able to represent the world in an efficient way that will allow for real-time communication, real-time speech, real-time video, that sort of thing.
Yeah, you're right. And it's tempting to make predictions that this is very far away. But as we've seen, things move really fast sometimes. The stuff that's coming out with respect to music is really incredible, but it's also not real time. And the one benchmark to consider here is whether you can do simultaneous translation. People care about having simultaneous translation. There's big companies that care about it because it means you don't have to take translators with you. There's large organizations that care about it because the UN then can be just having a much more efficient experience on their floor. Wow, is it a hard problem? The idea that I can be talking right now and that there's someone right to my terms of the order here, maybe just sort of right below me, who can be with only half a second, maybe delay or a second delay, be translating the concepts that I'm saying. It's extraordinarily different than what machine translation does. Human translation is trying to do almost a sentence by sentence experience, but here it's more the conceptual experience in order to make that fast enough. And we do not have any good solutions for this. And I think this is probably akin to all of the problems that we've described here with respect to understanding empathy, etc.
What do you believe are the constraints on solving that problem? Do you think it's a understanding of art model architecture? Is it a hardware issue? Do you feel like any of these things will be breakthrough points?
I think it's largely data. We have tremendous amounts of data for doing machine translation. For doing simultaneous translation, we have UN, which UN data might actually be around this kind of good stuff. I
I would
don't
imagine
know how
you
much.
have tens of thousands of hours of recorded UN simultaneous translations. For context here, I used to be a translator. I was never a
Oh, wow.
I was never a simultaneous translator, but I would uh, what's the other variety? I can't recall, but basically taking part in meetings with lawyers and translating back and forth between lawyers and clients. And this was a profession I was pursuing, and I was fairly close with some people who did become simultaneous translators. And it is amazing to think of the sort of computational training that they are enhancing, specifically one part of their brain to be able to instantly code switch in their heads at the speed of human language. And it's very unique and it requires years of training to get right. Yeah, it's wild.
What happens in that when they're working on it themselves?
It's like practice. It's like somebody trying to become a concert pianist is they just perform and perform. And of course, they're also working to close gaps in any vocabulary that they might be missing, domain experts in the variety in the fields in which they really want to concentrate, whether that be politics or economics or specific business areas. So there's vocabulary acquisition that goes along with that training. But a lot of it is sitting in a booth and doing the work over and
That's
over.
cool. Yeah, I really respect that a lot. Tens of thousands of hours sounds like enough, but I don't know. I don't know. I've not worked on the problem. Haven't really thought about translation seriously as a research endeavor in 4 years, but I do perceive that it hasn't reached enough of it. It hasn't reached it. It hasn't reached a place where people could say, "Hey, this is almost ready to tip over. Let's now just add translation features." There's no service that offers this. There's nothing that's good enough.
Switching gears a little bit, one thing that I really wanted to ask you about was this kind of world of multi-agent RL models. So you've done some work in this, right? So it's funny. So now in the Bay Area, there's all this excitement about LLMs and OpenAI's brand name is just like infinitely high. And of course, they started off doing a lot of these multi-agent models. My impression of how this went was that when the Transformer paper came out, then they built GPT and then they realized, oh, this is amazing. We're going to just like pivot into really focusing on this. But I guess what's become of that multi-agent work? What were they hoping to get out of that? And did it just not work? And are other people achieving their aims? Like what's the state of that field?
Yeah. Also, good question. I don't know their motivations in particular.
Yeah.
I will say that there was a long period where people thought that the way to get to general intelligence was through RL. The reward function was the most important thing, et cetera, et cetera. And you can learn everything through the reward function. Theoretically, that remains true, but in practice, it appears to not be as important as having tremendous amounts of data and a simple enough objective that still works for what you need. And it's the language models. With respect to where multi-agent stuff is happening, FAIR is still doing quite a bit of it, as you can see with Cicero, led by Noam and team. Then you have DeepMind, which of course has a bunch of people still working on this stuff all the time. I saw Feral recently put out a paper that was really interesting, the ADA one, which is all about adaptive learning and be able to do it with a small number of samples. A lot of this work is now building on top of foundation models and then adding RL to it, which is what you do with RLHF as well.
Sure.
I think that for the near future, it's going to, a lot of that core multi-agent RL type stuff is going to be relegated to academic labs more. I don't know how much is going to happen because everything is just super hot right now in working with foundation models and then pushing on that. Yeah. And there's also this feeling in academia that more and more people do the thing that's hot. It's pretty common. And then every once in a while, you're going to have this offshoot that comes around that pushes things forward and it's going to be surprising and it's going to work and then it's going to take over a little bit more. There are labs I can point to that will continue on this path because it's not going to be run over by the computational steamroller so much. There are important problems to think about that say around cooperation involving humans. It's rare that you're going to be run over by the computational steamroller if you have to involve humans in them. Yeah. It's just too hard to then do it. Now, maybe RLHF will lead to some route where you can have people who are every second are updating something, but you're going to have a huge team doing that. And there's a bet here, say even like the Forrester lab in Oxford is kind of making a bet that actually this is going to continue to be the case. And there are important problems. Frankly, right now, it just looks, all of research is being dominated by this stuff. And my old advisors at NYU certainly also are seeing that too. And every once in a while, you like something on Twitter or a comic or something about how all of ML research is now being taken over by these things. I would say that I think there's one direction though, which is maybe that answers your question in a positive light, and that's around robotics. OpenAI doesn't really do robotics anymore. They stopped. And they stopped because it's a different use of resources that isn't going to scale as well as this, as well as everything they're doing right now. Yeah. There are teams that are focusing on robotics. There's a team at DeepMind, a team at Brain. There's teams all over the world that are focusing on robotics still. And they have to bring together so many different parts of the stack. So they're starting to use LLMs in order to guide the progress of the robot or to make it do things that are human controllable. That's SayCan as an example. The paper called SayCan as an example. And they're also starting to do a lot more immense amounts of simulation and using all that data and figuring out how to do that in a proper way. So we're going to start seeing papers, many more papers come out with high amounts of simulation and then doing a little bit of sim to real using the fact that these LLMs have so much understanding of the real. And that's really cool. That's happening as well. But I think that those are areas that in terms of the multi-agent RL, I think you're going to start seeing it seep into robotics more than you have because some of the other problems that they've tackled, that they've been focusing on will be easier to address given the LLMs.
It does actually remind me of so I'm so old that, so I had the opportunity to take Jan LeCun's class in like 2010. And I remember thinking like, oh, like I know neural nets aren't cool. And he's just so obsessed with neural nets. I'm just going to go take like a class that's like doing hack learnability with VMs and stuff. And that's what I did. And huge regrets. I was obviously in retrospect a dumb decision, but Jan really had to fight through Benjio and these people who kept working on neural nets. Like they like the field really abandoned that direction and like other stuff got trendier and they had to just say, I'm just going to work on this anyway. And at the end, they were right. You can wonder if a lot of this kind of multi-agent stuff or RL, like the trend's going away, but like you can see what the potential is. And some of the people who just really stick with it might end up being able to.
That's causality today.
Yeah.
Oh my gosh. I think of causality as being that today. That everyone has, look, Facebook just dropped their causality teams recently. It was part of the firing. if you want to have something that will push these things to the next level, it's having causal understanding. Right. But we don't have real good ideas of how to bring causal understanding into knowledge. A lot of work on it.
Did you take a moment? Can you define what causality is as a field of research?
Oh, oh yeah, just ask me to define causality. Well, causality as a field. So causality as a field is trying. So I'll start by saying that there are really good conferences for causality. There's also a part of it which is in chat, the fairness conference. It collides somewhat with that direction. And also I'll put a quick pitch here for Jonas Peter's work. He's an amazing professor over at ETH Zurich, who's been doing this stuff for a while. Christina Heinz-Demmel, Martin Orhovsky, David Lopez Paz. These are really good researchers in causality. What you're looking for here is the ability to have some sort of the model, to give the model a causal understanding of what it's doing. And there's some toy examples here you could throw out. One of them is if you have a data set that has a really weird distortion around, say, women mostly have blonde hair, men mostly have brunette hair. And then in your test set, it's flipped around. The models will tend to do a correlation there. And if they see something with blonde hair, they'll predict it's a male. Whereas what you really want is for it to have a causal understanding, or to have an understanding that is hair does not predict gender, or sorry, hair does not predict sex. And that ends up being, the way you think about this is that the causal link is broken there. So in terms of the graphical model, it would look different if that was predictable, if sex was predictable by hair color. That's the toy problem that people oftentimes use for this. And you can get even more toy just by using some Gaussian models and then making predictions. And we just really don't have good ways to scale this up. That exact toy problem, I can point to a solution. Martin's got a great one in his thesis of how to solve that one. But in terms of scaling it up to full data sets, real data, et cetera, doesn't work. And going from A to B on this is really important if you want these things to actually have some sort of core understanding of what they're doing. So I think that there's this general hope right now in the field that when you go from 200 billion parameters to 200, maybe 2 trillion parameters, that it just solves. It just happens. But there's no scientific reason to think that it's true.
Interesting.
And so I think a lot of this has been forgotten because the work is it's just working so right now. But by forgotten, I just mean it's been put to the side.
Yep. So what we're talking about here is perhaps an embedded notion of how the world works, perhaps an idea of internalized physics or understandings of the kind of structure of the environment in which it's being trained, rather than just correlations about entities, which, to be fair, LLMs really seem amazing, but they are at their core really just predictions of next token.
Yes. And so what you're pointing at is something a little different as well. You're pointing at is having this embedded world model and being able to condition on some world model. That's different than having a learn from data causal understanding. There's different things we can point to and say which is better or which is worse. The RL world will oftentimes say that actually what you want is these world models. And that's not always true too. We're talking about model free versus model based. But in terms of causal understanding, I think what you're saying is a great next step. If we can get to the point where we can use these world models in a reliable way, A+, involving physics into things, A+, awesome. But what we ultimately want is for it to be able to causally learn from data. And so when you go about the world of the human, you can learn that this mirror sits upon this desk. If the desk moves out of the way, the mirror will fall. It's not clear at all that we bring into that experience any sense of this world model physics. Instead, we have some just causal understanding that this desk is upholding this mirror.
Is it even conceptually, like this seems like actually philosophically difficult, right? Was it Hume who had that thing about how causality just can't be inferred from data? Because you're really reading into your data. You're saying like, oh, like I've seen this correlational structure before, but really there's these kind of like rules underlying that. And okay, like, and so some things that I see are because of the rules and some things that I see are due to randomness in the environment. I'm going to go through and sort of decide like which things are which. And for this like rule set, which I'm then going to believe, but even my rule set might have problems. So I also have to have uncertainty about my rule set, right? Is that even concept? Like, it almost seems like a philosophical problem.
Like, I guess to some degree, it's also empirical because I do believe there's evidence that some sort of core understanding of physics is baked into the model, like pre-baked into the model. So it's not being derived actively from interaction with the world. So it's very interesting to me to think about what elements of this are hardwired in the circuitry and what elements of this are learned through interacting and getting that feedback from the world.
Yeah. No, these are good questions. And with respect to the philosophical thing is another one you could ask is, do we even need it to be causal, or can you just have strong enough correlative things that it actually ends up just being fine?
Yeah.
And there's no real issue. We don't have the answers to this. And because we also don't have the answers to what humans are doing with this.
Yeah.
I have a suspicion that if you want to get to a place where you can have reliable answers come out of a model as to what it knows, what it doesn't know, you want it to have some underlying facility for doing this.
Yep.
And perhaps that facility is not purposely done. It's not built into it prior to the model. Perhaps it just emerges, but you need to be confident that it exists. And it doesn't exist today. But the research into how it could exist, that's what I mean by the field of causality.
Yes, that's a really interesting question.
Perhaps we could wrap up with a question about a recommendation for listeners, something that you've read or are reading or have been watching, or a game that you're interested in sharing. What's a takeaway from our conversation that you think you'd recommend to somebody?
I think there's cool book recommendations, clearly. Things like Diamond Age, Ender's Game, which we discussed earlier. Another one along those lines, which I was reminded about from a friend recently, is Rousseau's Take on Education, Emily. Those are some pretty clear ones if you want to think about this direction. I think with respect to the causality stuff, Martin Arhofsky's thesis is fantastic. It's very approachable. Yes, there's a lot of math in it, but if you want to ignore the math, it's very approachable regardless. And
Those are great. Yeah. And I also just wanted to ask, what's next for you? What do you want to build or research next?
yeah, that's fun. I might not figure this out exactly where I'm going to commit to, but I'm spending a lot of time thinking about childhood companion and how to use the modern tooling to really make something that can grow with a kid. If you can let's just imagine you have a child when they're 5 or 6, you get them to love and experience an interactive companion, and you grow with them over time. I think this will properly ride the wave of research, such that the clear ones around understanding more memory, understanding more empathy. I think that what you would have from this is the ability to form a lifelong companion. If the kid form a lifelong companion, is something that can really help them a lot. And all the tooling is on its way.
Very cool.
I really love that idea. I feel like I want a lifelong companion. I'm not even a kid.
Right.
Thanks so much for being part of Pioneer Park.
It's my pleasure. Thanks, guys. Really appreciate it.
Thanks so much, Cinjon.
Cheers.